Hello and welcome to this R tutorial. So in the previous tutorial we did the preprocessing phase, we imported the dataset and selected only the level column and the salary column. Then we didn't have to split the dataset into the training set and the test set because as you can see the dataset is a very small dataset with only 10 observations. And finally we didn't have to apply feature scaling. So that made this first preprocessing step pretty easy. And now we are ready to move on to the next step, which is to fit our polynomial model to the dataset. However, I would like to show you how the polynomial regression model is a much more powerful model for our situation. And the best way to show you this is to actually compare it to a baseline model, like a reference base model, which will be our linear regression model. That's why in this tutorial we will build two models, the linear regression model and the polynomial regression model. And then we will compare the results, we will compare the graphic results and also the predictions. So you'll be convinced that the polynomial regression model is a much more appropriate model for this problem, and the main reason for that is that our problem is a nonlinear problem. Okay, so let's start by building this linear model. It's going to be very quick because we actually already did this. So we start by creating our regressor that this time we're not going to call regressor because we will build two regressors, the linear one and the polynomial one. So we will call it linreg. Here we go. And then later we will call our polynomial regressor polyreg. So linreg equals, and then remember we have to use the LM formula. And so we need to add some parentheses here. And then let's remind ourselves what we need to input by pressing F1 here to have a look at the arguments. Okay, so remember the first argument is formula. So the formula is very simply the salary, that is our independent variable, tilde. So I just pressed Alt N and then a dot here to take all the independent variables, but actually there is only one independent variable, so the dot here is strictly equivalent as just writing level. Okay, so perfect for the first argument. And then what is the second argument? It's data. So data, okay, so let's add this argument. Data equals, and now let's see. Okay, so in the linear regression section, we actually used the training set here as the data argument to train our linear regression model. But as we explained before, here we did not split the data set into the training set or the test set. So we are simply going to train our model on the whole data set itself because it's a small data set anyway and we want to have the most accurate prediction. So here simply we will just input data set. All right, and our linear regression model is ready. We are actually ready to build it. So let's just do it. Let's build our linear regression model. I'm pressing Command and Control plus Enter to execute. All right, linear regression made. We can have a quick look at the summary here. Summary linreg. So I'm typing this in the console and pressing Enter. And here are the statistical results of the model. We're doing this on R because as you can see it's really easy. On Python we would have needed to import a class, create an object, but here it's really easy. So we can have a look and we can see that the level has 2 stars here for the level of significance and is actually not a bad predictor of the salary. But wait for the polynomial model to see how it's going to be much better than linear regression. Okay, so now let's move on to the next level, that is the better model, polynomial regression, and let's build it. Okay, so as I mentioned, we're going to call this regressor poly_reg. All right, this way. And since the polynomial regression model is actually a multiple linear regression model in which the independent variables are actually the polynomial features of one independent variables, as Carol explained in the intuition tutorial, well, we're going to use again the LM function as we did for linear regression. So here I'm just going to start by taking my LM function, add the parentheses, and we're going to input our 2 arguments, formula equals salary tilde, alt n, and then this dot here. but don't worry, will actually represent something else. So far I'm just putting the dot and you'll understand what's going to happen next, which will make our polynomial regression build correctly. So then comma, and then we add our second argument, which is still going to be the data equals data set, because we're going to train our polynomial regression model on the whole data set. Okay, so now you must be telling yourself, wait, but this is exactly the same as linear regression. Well, that's true, and that's why we need to add a little something here to make this model a polynomial regression model. And this little something that we're going to add is actually the polynomial features. The polynomial features are actually some additional independent variables that are going to be the level squared, the level cubed, level to the fourth, level to the fifth, up to any degree you want. These are these additional independent variables that are going to compose our new matrix of features in some way, which will actually be the matrix on which we will apply a multiple linear regression model, which will make the whole model a polynomial regression model. So in short, a polynomial regression model is a multiple linear regression model that is composed of one independent variable and additional independent variables that are the polynomial terms of this first independent variable. Okay, so now that we get this idea, you'll perfectly understand what we're about to do right now when building our polynomial regression model, because what we're going to do is to build these polynomial terms. And to that extent, what we're simply going to do is to add specifically a new column here in this data set, which will be the level squared. So we're going to call this new independent variable level 2, and let's add this new column right now. So to add a column in a data frame, we need to take our data frame, so it's data set, here it is, and then we need to add a $sign here. And then we can add any name here, which will create a new column of this name and add it into our data set. So we're going to call this column level 2, because we're taking the level squared of our 10 levels. Then we add equals, and then we actually need to give the formula of the values in this level 2 column of our data set. And this formula is therefore the levels in our data set at the power of 2. So very simply, we're going to take all the levels of our data set by taking our data set and same adding this dollar here to take the level column, which is here. I just have to press enter. So by doing this, I'm taking the level column that is all the values of the level column in our data set. And now I'm going to take the square of all these levels in our data set. And so to do this, very simply, I just add hat and 2. That's it. That will just create a new column which will contain the squares of our 10 levels in our data set. So let's see. Right now my data set contains only 2 columns, level and salary. And if I execute this, here we go. Now let's have a look at the data set. As you can see, I now have 3 columns, level, salary, and level 2. And as you can notice, the values in the level 2 column are the squares of the values in the level column. Okay, and now we can build our polynomial regression model, because now this dot here not only contains the level column, but also the level 2 column. So this will build a multiple linear regression model where the independent variables are the original independent variable and the polynomial term of this first independent variable. And if you want to build a polynomial regression model with a higher degree, well, you would need to do the same here. You know, we can copy this line and paste it here and just add a level 3 column that will contain the cubes of the levels in the original independent variable level of our data set. And as you can see, it'll be very easy. I just need to execute this line, and this will add a level 3 column in our data set. And so now this little dot here will be the original independent variable level, the square values of our levels in level 2, and the cube values of our levels in the column level 3. You can add as many powers of levels as you want, but maybe we'll stop here. We will see what is the best polynomial regression for our model, and so we will see what we'll get with this one. And now let's actually build the polynomial regression model. If we select this and execute, press Command and Control plus Enter to execute, and done, our polynomial regression model is created. Awesome. So we're gonna have a look. Let's type summary in the console, polyreg, and let's press enter and let's see what we get. Okay, so now what we can see is that these level 2 and level 3 polynomial terms that we created are actually statistical significant variables. But actually this table here does not show the real deal of the polynomial regression model for our problem. You will be much more convinced in the next tutorial where we'll be visualizing the graphic results, and you will perfectly understand why our polynomial regression, which is a nonlinear model, will make a much better job at predicting what we want compared to this linear regression model, because it's a linear model. So we'll check that in the next tutorial, and until then,